Hello, we're going to take a look at a problem that's explained to us here in the blue font at the beginning. So for a certain population, the growth rate G, measured in thousands per year, depends on the population N, measured in thousands. The given equation determines what is known as a logistic growth with a threshold of 8,000 and a carrying capacity of 50,000. Boy, that's a lot of words that did not make a lot of sense to me. So we're going to dive into this and see if we can figure it out. First thing that it asked me to do is to make a graph of G versus N and include population sizes up to 60,000. Okay. So populations and growth seems like it would be positive values, but I actually don't know because maybe a population could shrink and have a negative value. What I do know is that N, I'm told, is the population. So when it tells me N up to 60, this is really my X because I can see that I'm going to end up typing X for these when I go to type this on my calculator. X up to 60. All right, and I see that G, which is the growth rate, G is going to be my Y value. So I'm going to go to my calculator to try to get a sense of what's going on with this scenario. So in my calculator, I'm going to Y equals, clearing out my last problem, and typing in this big formula. So we had negative 0.76, and then there's an N, so I'll type X. And then there was a parenthesis. In that parenthesis, we have 1 minus. Again, we have X, or N, so X divided by 8. And that ends that first parenthesis. And then we started a new parenthesis where we had 1 minus X divided by 50. I did not have to put parentheses around the denominators here because the denominators were literally one number instead of any math. So I was able to type that exactly as it was given. When I don't know anything about a function, I want to look at values in the table. So I'm going to go second window to set up my table. The problem told me to look at values up to 60. So I'm going to start my table at 0, and I'm going to go up by 5s so that I get to 60 a little bit faster. And then I'm going to go second graph to look at my table. So I do see some negatives. I see positives. The highest positive I see is 26.93, but I do have to go to 60, so I'm going to scroll down here. Oh, negatives after that. Oh, very negative. So the highest number I saw on this entire Y list is 26.93. I'm going to want to go a little above that, so I'm thinking 30 for my maximum. And the smallest number I see is negative 59.28, so I'm going to go negative 60. So I'm going to use what I've done so far to set up my window. So it told me to go up to 60. So 0 to 60 in the X direction. That was in the problem. And then from looking at my table, the smallest we said was just below negatives, or just above negative 60. And the largest, so going down, was a little bit below 30. All right. So that's what I saw on my table. I'm going to see what the graph looks like. Wow. All right, so I see it looks like it sort of starts at 0, 0. When I was looking in the table, I actually noticed it does start at exactly 0, 0, because that's an ordered pair. And then it goes negative a little bit, hits the x-axis again, goes positive, and then really drops off. So I'm going to attempt sketching that. And usually when I draw it, it just helps me make sense of it. So we have our axis here. And this actually went down into the negative. So our x-axis was the population, which is N. And it told us to go from 0 to 60. And our y-axis is G, which equals growth. And our growth started at 0, 0, went a little negative, hit the axis, went a good bit positive and dropped off. So of course the one on the calculator was better, but we get the idea. So the first question is, at what population level does the greatest rate of growth occur? So I'm focusing in on the word greatest, and it's the greatest rate of growth, and we said that the y-axis was the growth. So the highest growth is going to be at the top of this graph, which I recognize as a vocab word about graphing, and that is a maximum. So my calculator is able to tell me that. So I'll go to my calculator, and I will use that second trace menu, and I see option 4 is maximum. So going down to option 4, hit enter for maximum. And it asks me questions, and I have to respond to them. So the first question is the left boundary. And for the left boundary, you need to literally be to the left of where you think the maximum is. And I think this is, so I'll hit enter. Now it asks me for the right boundary. So I have to use my arrow. So I am literally to the right of the maximum. Hit enter. And then it asks me for a guess. And what it's going to do is it's going to check for the highest value in this section. So if I was not to the right or to the left, it would still give me the highest value in that section, but it wouldn't give me the correct answer. So I have to make sure that I am clearly to the left and the right of the actual maximum. And so I hit enter. And so the maximum, highest it ever goes, is 34.8396 and 26.93. Let's go 2 decimals. So 34.84 and 26.93. So going back to my drawing, this maximum has an ordered pair that I got from the bottom of my calculator screen, 34.84, 26.93. Now I have to think about what did it ask me and which number is going to answer that. So it asked me at what population. So looking at the labels on my graph, population was the x-axis. So this is the population. So at what population? Well, at 34.84, and it did tell me up here population measured in thousands. So at 34.84 thousand, that's when the animals were growing the fastest. Okay. Next question. There are 3 values of n where g is 0. Okay. 3 values of n. N is the population. 3 population values where g, growth, is 0. Find these values. Explain what is happening at these levels. How do they make sense? All right. Well, finding the values. I can see one of them is right here. And we actually talked about that before, that this goes through the point 0, 0. So that is a place where the growth is 0. The next one is where it comes back across the axis. So that's this point. And the third one is where it crosses the x-axis yet again. So I'm going to go to my calculator to get those additional zeros. We know that the 1, 0 is at 0, 0 because we saw that in the table when we set up the graph. So on my calculator, I want to go second, trace, and I want to go to option 2, find a 0. I have to answer the questions. It asks me for the left bound, so I'm using my left arrow to go to the left of the first 0. So here I am to the left. Hit enter, move to the right of that 0. Hit enter. Hit enter one more time, and I get that 0, that place that it crosses the x-axis, is at 8. Now I'm going to repeat this to get the second 0. So second, trace, option 2 for 0. Left boundary, so I'm going to go over here near the second or third 0. And this time I'm a little above, but I'm to the left. Hit enter, go to the right. That's further than I need. There we go, a little to the right, enter, and hit enter to guess, and that one's at 50. So what I have figured out is that we get a 0 at 8, 0, and another 0 at 50, 0. So it told me there are 3, and I found those values of n. So those values of n are 0, 8, and 50. Explain what is happening at these population levels. Well, the growth of the population is 0. So growth is 0. It's not shrinking or growing. So then it asks, how do these make sense in the context of the problem? Well, this is a population. I assumed it was animals because it talked about a carrying capacity. And so that to me indicated that it was a number of animals on a restricted amount of land or in a restricted environment. So this first ordered pair made sense to me because this said the population was 0 and the growth was 0. So at 0, 0, there are no animals because the population is 0. And there is also no growth because they can't reproduce if there aren't any. So that one was easy. Next one, the 8 and the 0. Well, the 8 is mentioned in the problem, and it says threshold of 8. So the threshold means that is the minimum population required to establish this animal. And so this one was the threshold equals minimum to not die out. So prior to that, we see this negative. So we see the growth is negative. So if a smaller population is introduced, there would be too many predators, and over a period of time, that population would die out. But if the population was at 8,000, it would not have growth or decay or shrinking. So every animal that died, there would be an equal number born, and so the population would not shrink or grow, it would just stay flat at 8,000. And then the 50,000, the last one, this 50,000 is the carrying capacity. So 50,000, I'm going to use K there for 1,000, so 50K equals carrying capacity. And we talked about that in one of our other examples a couple weeks ago. And the carrying capacity is the number of animals that an area of land and environment can support. So if you have more animals, there's not enough food. And so when you have how many it can support, there's only enough food that if one dies, one is born, it's not shrinking or growing. Next question. What is the rate of population growth if the population size is 42,000? Well, this says population size, so I know that this is an X value. And that's helpful because I can find that on my calculator very easily. So on my calculator, I'm going to go second, trace, and enter for option 1 value at 42. And I get 21.706 if I round off. So at 21.706, population is, the growth is 21.706. Well, what does that mean? Well, when I look back at the problem, it says the growth is measured in thousands per year. So 21.706 thousand, it's growth, so new animals per year. All right, so we're getting a lot of new animals. All right. What is the population growth rate when we're at 52,000. So again, just going to go to my calculator, second trace value, enter 52, and I get negative 8.694. So this one, the growth is negative 8.694. So this is not a decimal here. That's a pen mark. So negative that. So what does this mean? Well, this means thousands. And the negative here means that the population is shrinking or decreasing by 8.694 thousand per year. So if I try to make some sense of that in the problem, we had noted that the carrying capacity, the environment here, can only support 50,000. And so when we're having a population of 52,000, our population has exceeded the resources. And so that population is going to start to die out. And so that is what's happening with this negative growth. That means the population is actually decreasing at that point. So hopefully this example helps you to walk through creating the graph and then different features on your calculator. So we actually used a bunch of different features on our calculator. For greatest, right here in the second one, we used the maximum. For zero, we use the zero function on our calculator. And for the 42,000 and the 52,000, we use the value function on our calculator. So this problem is all about using the features on your calculator to answer the questions.